Divisibility rules for powers of 2. First, we're going to do some number theory. If you want to skip right to the rule, it's on the last slide. Let's look at powers of 2 and powers of 10 and see how they're connected. Since we're working with the decimal system, 10 is very important. 2 to the 1, if you multiply it by 5, you get 10. Notice what happens when I square 2. 2 squared times 5 squared can be rewritten as 2 times 2 times 5 times 5, or 2 times 5 times 2 times 5, which is 10 squared, which equals 100. 10 squared is more important for number theory purposes. Focus on the 2. Likewise, 2 to the third times 5 to the third is the same as 10 to the third, which equals 1,000. So now look at the pattern. 2 to the 1 is a factor of 10 to the 1, which has 1 0. 2 squared is a factor of 10 squared, which has 2 zeros. 2 to the third is a factor of 10 to the third, which has 3 zeros. So we could extend this 2 to the n times 5 to the n, which is the same as 10 to the n, which will look like 1 followed by n zeros. All of this background is why the rule for powers of 2 and divisibility works. Let's see more. Here's an example. 73,016. Is it divisible by 8? Well, keep in mind that 8 is 2 to the third. So we know that 10 to the third, or 1,000, is divisible by 8. So let's rewrite 73,016 as a multiple of 1,000 plus 16. Automatically, this is divisible by 8. Because 1,000 is divisible by 8, when you multiply it by 73, you get another multiple of 8. And 16 is also divisible by 8. We have a sum of two numbers that are both divisible by 8. A multiple of 8 plus a multiple of 8 creates another multiple of 8. So the answer to this question is yes. And we're getting very close to using the rule. Let's see what it is. According to our powers of 2 and powers of 10, if you want to know if a number is divisible by 2, you just look at the last digit. The rest of it is a multiple of 10, which is a multiple of 2. For 4, you only need to look at the last 2 digits because the rest of it is a multiple of 100. That's a multiple of 4. For 8, it starts to get a little more challenging to work out in your head, but you should focus on the last 3 digits because 8 is 2 to the third. And for 16, since it's 2 to the fourth, you're going to look at the last 4 digits. It turns out that 412 is not divisible by 8, so this number is not divisible by 8. Similarly, 6,412 is not divisible by 16, so this number is not divisible by 16. So the rule is, for any power of 2, look at the last n digits. If that number is divisible by your power of 2, then the entire number is divisible by the power of 2. So that's the rule and the theory behind it. Now go make it useful.